Hi guys, and welcome back to another video. So today we're given the problem, determine the moment of the force about point O. So first, when we start out this problem, just recognize that the only force they'll be using to calculate this moment is that 100 Newton force, but you see it's at that 3, 4, 5 triangle right there. I'm going to want to split it up into an x and y component to make finding the moment a little bit easier. So let's start off with the y component of this 100 Newton force. So it's going downwards, and it's going to be that 100 newtons. And then I'm going to use the 3/5 because that is the opposite side of our 3, 4, 5 triangle. So you have 3/5 right here, and then that is going to yield just 60 newtons. So that's the y component of that force. Next, let's move on to the x component of the 100 newton force. So that is going to be 100 newtons, and then we're going to use the adjacent side of that 3, 4, 5 triangle. So it's going to be yielding 80 newtons. Next, now that we've found out the x and y components of this force, we can now move on to finding the sum of the force moments about point O. Now, I like to use clockwise positive. You can use counterclockwise positive as well. Either way, we should be getting the same answer once we find out the final one. And now we're going to find out the sum of the moments about point O is equal to, so let's first start off with this 80 Newton force that we found. So if you look at it, it's pushing this way. So it's going to create a, if you see it pushing this way, it's going to create sort of a clockwise motion of this bar. So now that we're going to find that out, it's going to see that's going to be negative because it's pushing it clockwise. And then remember that the distance that you always use for a moment is always the distance that's perpendicular to where the force is pushing. So what I mean by that is you have this 80 Newton force right here. So you see the line right here that I drew to see where the force is going. This 2-meter distance is perpendicular to that 80 Newton force. So therefore, it's going to be times 2. And then next we're going to move on to the 60 Newton force. The same thing happens with that 60 Newton force. It's pushing it downward. If you picture that bar rotating from that downward force, it's going to be rotating clockwise, which is therefore going to be negative. And then that's going to be times 60. And then the distance that is perpendicular to that force is 5. So therefore, we're just going to plug in all those numbers. I should be getting negative 460 Newton meters. And then let's turn that into our final solution would be, which would be 460 Newton meters. And then that is going to be in the clockwise direction. And then that is our final solution. Perfect. Thank you guys, and have a great day.